So the program is asking us to iterate from angle 0 to 360 and generate the sine value for each angle. Then move the turtle to that position, leaving a line behind. And so before we get into this, we do need to talk about sine. And so going back to geometry, we have a unit circle here where we have 1, 1, -1, and -1 here. And we're drawing the circle like that. And then we are thinking, and here's the y-axis, here's the x-axis. X corresponds to cosine, and y corresponds to sine. And then the angle determines what sine and cosine are. Okay, so then the angles we usually think about in terms of degrees, right? Like I'm aiming my artillery and I need to raise it to 30 degrees so that I could hit the target, knowing the amount of gunpowder I put inside the cannon, right? So we usually think about things in terms of degrees, but here we're talking about degrees in terms of radians. Okay, and radians is just another way to represent degrees. So then we're right up here, and this would be 90 degrees, right, straight up. And so if you shot the cannon at 90 degrees, it would fly up and fly straight back down. And in radians, this would be pi over 2. Okay, and then this angle here is 180. Okay, like here's 0, and then we come up to here, and that's 90 or pi over 2. And we come over to here, and that's 180, right? A straight line. And in terms of radians, it's pi over 4. Oh no, I'm sorry. No, it is pi. And then we have the angle 270, which is 180 plus 90, right? And 270 degrees in radians is 3 pi over 4. And then that takes us back to angle 360, which makes a full circle, and that takes us to 2 pi. All right, so that is the unit circle, and those are the degrees. Those are the radians, or the angle around the unit circle. And so we need to calculate the sine, which is the y, the amount of movement on the up and down. Okay, and so when you think about sine, the way that most people see a sine wave is not in the unit circle but horizontally. And so we get this curve here, and this here is 0, this here is pi, and over here is 2 pi. And then we have this little line here, which would be 3 pi over 4, and we have this line over here, which would be pi over 2. All right. And this axis is the amount of degrees, right, or the amount of angle, and this is the amount of in radians. And then up here, this is the y-axis, so that means that this would be 1, and this would be -1. So this diagram and this diagram are two representations of the same thing. Just one is mapped on a unit circle, and the other one is mapped horizontally, right? So, okay, so we need to take this and we need to graph this using Turtle. So how are we going to do it? Well, we're not going to be doing things in terms of radians. We're going to be doing things in terms of degrees. So we will go from 0 to 90 degrees. 0 to, yeah, that's right, 90 degrees to 180 degrees. To 270 to 360 degrees. Okay, and so the way that we're going to do that is we're going to have a for loop with the iterating variable starting at 0 and iterating. So every time the for loop iterates, it adds 1 to the iterating variable, and then we go 0, 1, 2, 3, 4 up to 90, 91, 92, 93 up to 180, 81, 181, 82, 83 up to 270, and all the way up to 360. So we have a for loop that looks like this, for I, or you can call this angle, right? This is a temporary variable for the for loop, in range. And where do we want to iterate I up to? Well, we want it to go up to 360. So now what are we going to do? Well, now we know the angle because I is going to be the angle, right? I starts at 0. Now what we need to do is calculate the y position based on that angle. Okay, and the y position based on the different angles is the sine. Okay, so now we need to calculate sine based on I, or based on the angle of the diagram. And so how do we calculate sine? Well, luckily in the math module we have math.sine that calculates sine. So okay, great, we got sine. And sine, if you remember from here, is the amount of motion up and down, or is the y. So we're going to say y is equal to math.sine. But there's a problem here because we can't just put I in here, because I is in terms of angles from 0 to 360, right? In terms of degrees from 0 to 360. But the math.sine method takes in radians. All right, so it takes in like pi over 2 and 3 pi over 2 and 2 pi. So luckily what we have is we have another math function or math method, and it's called math.radians. And this guy takes in degrees and outputs radians. So I is our degrees. We're going to put that in math.radians. This is going to return the amount of degrees that is. The amount of radians that degree is. So then we could feed it to the math.sine method. And now this is going to correctly calculate how much vertical motion we have based on the degrees that we are increasing as we iterate through this for loop. So the first iteration of the for loop, I is going to be set to 0. And then it's going to check, is 0 less than 360? Yes, it is. So it's going to go into the body of the for loop, execute this line of code here, which is going to be math radians of 0, which calculates to 0 radians. And then we'll do math.sine of 0, which is 0, right? So y is going to be 0. So the first point is going to be at 0, 0, right there. And then it's going to come in, it's going to finish the body of the for loop, come back up. I is going to increment from 0 to 1, and then it's going to check, is I less than 360? Yes, 1 is less than 360. That's true. So it's going to come into the body, and it's going to do math.radians of 1. And then that's some radian expression that's given to math.sine, and now y equals some small decimal place right here. Okay? So yeah, and then as I increments upward to 90, it's going to continue increasing, or the result of this expression is going to continue to increase. And then once it hits 90, and then from 90 to 270, this expression here is going to continue to decrease, right, until we get down to -1. So we need to use this. And so the way we're going to use it is, let's assume we have a turtle, t. So we're going to say t.goTo. And goTo takes in 2 arguments. It takes in an x and a y. And if you remember from our x-axis is represented by the angle, right? And we're using I as our angle. So we say I here. And of course, if this confuses you, you can use the word angle here as a temporary variable for the for loop. So that might make more sense. So you would use angle here and then feed angle into radians. And then you would go to angle on the x-axis. And then on the y-axis, you would just use y, right? Because this math.sine of the radians tells me how much to move up and down on the y-axis. So that's our y. And yeah, if you run this, what you're going to get, if I draw it over here, is, here's your screen. You're going to get this, where it looks like your turtle is not moving at all. And why is that? Because if you remember, we do have an x and a y axis on our screen, and this here is 300, 300 on the y, negative 300 on the x, and negative 300 on the y down here. And if you look at our sine graph, it goes from 0, oh, I'm sorry, no, you won't get this. You'll get a single line that looks like this, right? And so why is that? It's because of the perspective, right? So sine fluctuates up and down from -1 to +1. And so on this map here that goes from 300 to -300, you can't see that motion. Okay, so then the last little chapter, it talks about using WN, the screen dot set coordinates, and WN dot set coordinates takes in X and a Y and a second X and a second Y, and this way we can adjust the size of the screen so that we can zoom in on the Y-axis, right, so that we can actually see this curve happening. And so how does that work? Well, the first point, the first X and the Y represents the bottom left corner of the screen, and then the second X and Y, or I call it X1, Y1, and X2, Y2. The X2, Y2 represents the top right corner of the screen. So if you set these purposefully, you can zoom the screen into this area right here, right, by setting the bottom left corner to an appropriate number and the top right corner to an appropriate number. And then if you run it, you will get this. So, sorry for the chicken scratch. My handwriting is atrocious, but there you go.